Enums 1. Ooh, enums. Enums are fun. To do, define few types of messages as used below. Okay, so it's just looking for these 4 values. Right? Quit, echo, move. You can see them changing to purple as I type them in. Change color. Right? And then this should format it nicely. I guess the order doesn't really matter. And then there we go. And we got the output. Wikipedia says algebraic data types are the best. They are really, really cool. I agree. All right, so what's next? We have enums 2. Force and Forte, thank you for the follow. Welcome. Okay, so this to-do says define the different variants used below. And I can see here we have a struct type, we have a tuple type with a string, we have a tuple type with numbers, and we have a bear type. I don't know what you call these, but we can create each one of these. So we have move with a struct that contains an X and a Y. Right? So now that one turned purple. We have an echo type which takes a string. We have change color, which looks like it takes the U8s again. And we have the quit type. Is that all we need to do? Yes, that is all we need to do. So what's next? Enums 3. To do, implement the message variant types based on their usage below. Is it the same ones as before? So we need to get it to compile, we need at least these guys. So it's the same ones. Oh, this takes a point though, and not just an XY. So this is a tuple type now, which makes it slightly different to enums 2. That's okay. We have point defined here, and we have state defined here. None of those use state. Okay, so let's get the code to compile again. We'll start with the very first error, change color. And again, we'll do U8, U8. We'll do the echo with the string type. We'll do move with the point type. And we'll do quit. And let's see, does that compile? It compiles. And the one test that we have failed. Okay, so now we have to fix the code. What is this code doing? We have a state struct, which contains a color, a position, a quit, and a message. Change color takes this and sets the color. Quit just sets quit to true. Echo takes a string and assigns it to message. Move position takes a point and assigns it to position. And in process is the to-do. Create a match expression to process the different message variants. Remember, when passing a tuple as a function argument, you'll need extra parentheses. Okay, so I can say match message, and then have Rust Analyzer fill in my match arms for me. Okay, so I think what they're looking for is we have a mutable reference to self here. So we just call each one of these functions based on what's being passed in. We can say RGB here. And this would just be self change color, RGB. And this is where we have to do the double parens to make it a tuple. Echo, self echo. We'll pass in the string. Is that a string? That is a string. Okay. We did take ownership of message, so we're allowed to take ownership of the string inside the echo and then pass it to echo. Move takes a point. Self, move position. Point, just P. And then quit, self quit. Nothing to pass in there. So let's see if that works. Ta-da! And again, we're getting these warnings here because they're only used in the test and not used elsewhere, but that's fine. All right, next up is strings 1. Expected a string, found stir. Well, that's easy enough, right? We can just say toString. There also is toOwned, which is classic Rust. I don't wonder if Clippy will warn us about that. No, Clippy's fine with it. But toString, I think, is the currently accepted way to do it. We could also do, I mean, there's a bunch of ways, right? We could also say string from. That also works. But I'm going to leave it like that. All right, what is strings 2? Mismatched types. Okay. To do, fix the compiler error in the main function without changing this function. Okay, so it's expecting an ampersand stir, and we're giving it a string. And it says, don't change this line. Don't make it a stir. But what we can do is make a reference to a string using ampersand, and that automatically gets converted to a reference to a stir. Because there's something in the library which does that for us. All right, very good. Next, strings 3. Trim me. Remove white space from both ends of a string. Add space world to a string, and replace cars in the string with balloons. Okay. I know that there's a trim begin and trim end. Let's take a quick look at Rust. Stir, trim, end. Sure. There might be something in string. What are we being past? We're being past a stir. That's fine. Okay. So let's take a look at the trim. We have trim end. We have trim left. And deprecated. Trim right, I bet you, is deprecated. Yep. And then trim start. And says with the leading white space removed. There's no trim both ends. There's trim. There it is. Returns a slice with leading and trailing white space removed. Okay, so we can do that. Input dot trim, and it returns a string slice. So it's returning this thing, and there's an implicit lifetime here which matches this one. So I think it's fine. Again, I like to fix the compilation errors before we do anything else. This says add space world to the string. There are multiple ways to do this. It's taking in a stir and returning a string. So from my point of view, the easiest way to do that would be to use format. So this is the way I'm going to do this. Input space world bang. And that generates a string with this in it. And then replace me. Replace cars in a string with balloons. And is there a replace? Or do I have to convert it to a, no, there is a replace. Replaces all matches of pattern with another string. So we can do that, and that's returning a string. And this does in fact return a string here. So that's perfect. So we can just say input, replace, cars, balloons. All right. And that passes our test. So I think they're just trying to show you the different ways of manipulating strings. I think that was the purpose of that one. Strings 4. Calls of this function should be replaced with calls of string slice or string. String slice or string. Oh, I see. I see. So what we want to do is change all of these. We have to decide if each one is a string slice or if each one is a string. Well, I mean, this is a string, so we can say strings slice. That seems to have worked. This says toString, so I bet you it's a string. This says string from high, so I bet you that's a string. Rust is fun to owned. Okay, so here they're doing to owned, which is the same as to string. So that's just a string. This is doing an into. So this is what Scoops was talking about here. You can convert a string into, or a stir, ampersand stir, into a string using into. I think, though, the into is still converted to this, right? There's a identity into. Anyway, this looks like a string as well. Warning, this is byte indexing, not character indexing. Character indexing can be done with schar's nth index. So this is a string slice. This is doing a trim. We already saw trim returns a string. Oh, wait. What did it return? I forgot. I forgot to remember. It returns a stir. Okay, so that's a string slice. Happy Monday, replace Monday, Tuesday. We remember that one returns a string. And my shift key is sticky to lowercase. Well, we can look that one up. To lowercase. And returns a string. That's a string. Did we get them right? Yay, we got them right. Oh, and placeholder is dead code, which is what we want. There, now it's clean. Scoop says, I wonder if there's an impl from T for T, so it might work for either font. We're going to try it. We're going to try it right now. Oh, interesting. So it does work. It's just redundant, and Clippy says, hey, you don't really need the into. So I'm going to leave it this string. Very good. Mukafa says, I think that's the case as well.